welcome to the Deep Dive. Today we're taking a really interesting look into railway manufacturing.
Yeah, a fascinating area.
Specifically, we're focusing on Iscar cutting tools and their innovative solutions. We've got some excerpts from their own material. Iscar cutting tools for railway industry. And the mission today is really to unpack how their tools are meeting these, critical needs of the railway sector.
Exactly. It's about understanding how Iscar's tech helps build railways that are, more efficient, precise, and really built to last.
Okay, so let's set the scene a bit. The railway industry, it has some pretty demanding requirements, right?
Oh, absolutely. Very unique challenges.
Looking at this material, things like efficiency, precision, durability, they aren't just optional extras, they're fundamental.
Non-negotiable, really.
We're talking components under huge stress, passenger safety paramount, and these incredibly strict quality standards. Plus, they're often machining really tough stuff.
Yeah, like high-strength steels, advanced composites, that's a major hurdle right there.
It is. Machining those advanced alloys effectively needs tools that can handle extreme forces, but also keep to super tight tolerances.
And any tiny error, it could have serious consequences for safety, for the lifespan of the equipment. It's critical.
So how does Iscar approach this?
Well, the material shows they offer a really wide range of tools. Turning, milling, drilling, threading, the works.
A comprehensive lineup.
But it's more than just variety, isn't it? It's the tech inside those tools. They talk about exceptional accuracy, really smooth surface finishes.
Right, and using advanced materials and coatings themselves.
And what does that actually mean for the railways?
Well, that's where it gets interesting. Think about longer tool life. If tools last longer.
Fewer changes, less downtime.
Exactly. Less downtime boosts efficiency, cuts costs. Simple as that. And when tools perform consistently, even under tough conditions, that directly helps reliability and ultimately that all-important safety factor.
The source also makes a point that they don't just, sell tools off a catalog. They seem focused on custom solutions. Yeah, working closely with clients, fine-tuning the machining processes.
Which makes sense, given the variety of parts, huge wheels, axles, smaller connecting bits.
That collaborative approach is key. It lets Iscar apply their specialized know-how to specific problems manufacturers face.
Whether it's the scale of making wheels or the complex shapes for axles.
A tailored solution can really mean big improvements in efficiency and the quality of the finished part. It's about optimization.
Okay, let's really get into those materials now. High-strength steel. Composites, they seem central.
They are. And Iscar confronts this with advanced cutting materials and specialized coatings.
We're talking things like extra hardness to resist wear, staying stable even when things get really hot during machining.
This is where the material science really shines. These coatings, these carbide grades, they're engineered to keep their cutting edge sharp for longer.
Even against those incredibly tough materials.
Right. And the impact. You see less tool wear, definitely more consistent performance over time.
Which means fewer interruptions for maintenance or tool swaps, right? Lower costs again.
Precisely. Reduced downtime is a huge benefit.
Let's get specific. Rail wheels.
Yeah.
Big topic. Iscar has tools just for them. For making new wheels on vertical lathes, they use tools with round inserts.
Yeah, that's pretty efficient for roughing out the initial shape, removing a lot of material quickly.
But what about worn wheels? They need returning, right?
Right. And that demands real precision. So for that, Iscar offers tools with interchangeable cartridges. These hold tangentially clamped inserts.
Okay, tangentially clamped. Why is that important?
The material highlights it ensures really high-profile accuracy, and that's vital for how the wheel sits on the rail, for safety, for a smooth ride. You can't mess that up.
Makes sense. And it's not just wheels. Locomotive wheels machined on underfloor machines. They have special milling cutters for those too. And then for things like switchers, track profiles, separators, connecting links,
right.
They mentioned extended flute milling cutters based on their Tan Mill and Helitang tech.
Often using those tangential inserts again.
So that tangential clamping design, it seems like a recurring theme. It must be pretty important.
It really is. The source explains it creates a much more rigid tool structure.
Okay, more rigid.
So that means better dynamic performance. Think about challenging cuts. interrupted cuts or machining really hard materials.
Like that manganese steel.
Exactly. That rigidity helps handle those tough conditions. It's especially good for milling the curved profiles on switchers and separators, particularly in manganese alloyed steel, which is notoriously difficult to machine.
Right. You mentioned manganese steel. The source talks about machining sidetrack profiles and connecting links too.
Yeah.
D490 extended flute cutters for the sidetracks.
Yep.
And then the really tough job, those connecting link blades made of manganese steel.
Yes, that's a classic challenge.
Apparently, Iscar's tang mill cutters, the ones with face-mounted inserts, are the solution there. They help reduce cutting forces.
Correct. Reduced forces, better tool consistency, and really smooth cuts.
And smooth cuts mean less finishing work afterwards.
Exactly. That's a big efficiency gain. Fewer steps saves time, saves money. Plus, lower cutting forces on manganese steel helps prevent tool damage and maintains accuracy. It's a win-win.
Okay, let's shift gears slightly. Locomotive power systems. There's a big push for sustainability there, right? Hybrids, alternative fuels.
Definitely. Reducing emissions is a major focus.
And Iscar's tools are involved here too. Machining engine and transmission parts.
Yes, they enable the really precise machining needed for those components. Everything from rough milling to fine finishing, drilling, thread milling.
So by making tools that allow for that precision.
They're indirectly helping develop and implement these more sustainable railway technologies. The accuracy of these tools impacts the performance and longevity of these advanced power systems.
And sustainability isn't just an indirect benefit. The material says Iscar actively focuses on it. Tool designs, cutting parameters, aimed at minimizing waste.
Yes, minimizing material waste and also reducing energy consumption during machining.
And because the tools are high performance, faster machining, better efficiency.
It leads to significant cost savings too. So you get this dual benefit.
Environmental and economic advantages.
That's quite compelling, isn't it? By focusing on tool performance and longevity, they help customers cut costs and operate more responsibly. Less waste, less energy, it all makes a difference.
One last point the source stresses is customer support and training.
Crucial.
Things like on-site consultations, technical workshops.
Yeah, helping railway professionals get the most out of these quite sophisticated tools.
So they can maximize performance, achieve operational excellence.
Absolutely. With complex tech like this, that support is vital. It ensures customers use the tools effectively, get the best results, and it builds strong partnerships too.
So pulling it all together, it seems Iscar is offering more than just tools. It's expertise, comprehensive solutions.
Right, directly tackling the railway industry's needs for precision, efficiency, durability, especially with those tough materials and complex parts.
They're really positioning themselves as a key partner for the industry.
Exactly, helping railways meet today's demands and prepare for the future with that focus on sustainability and continuous improvement.
It really makes you think, though. As the railway industry keeps evolving new materials, bigger sustainability goals, how will cutting tool tech continue to shape things?
That's the big question, isn't it? How will these innovations impact not just manufacturing, but the whole future of our transportation infrastructure?
A fascinating thought to leave you with. Thanks for taking this deep dive with us today.